Hi all, today we're going to end our discussion on factoring with chapter 7-8, which is factoring polynomials completely. So we're going to use all of our skills from our previous sections and add one new one from today. So I made you a flow chart of kind of what to look for when you are factoring. So the first thing you are always going to look for is a greatest common factor. And if a polynomial has a greatest common factor, you're going to factor it out front and you need to leave it out front. Don't get rid of it. Then what you do next is going to be based on how many terms the polynomial has. So if the polynomial has 2 terms, if it's a binomial, the only way at the moment you know how to factor a binomial is if it's a difference of squares. So remember, a difference has to be subtraction, and then each term is something squared. If it happens to fit into that pattern, you're going to factor it into a plus b and a minus b, which remembered we called conjugates. If it's a sum of squares or anything else, at the moment we don't know how to factor those. This is the only thing we've talked about for binomials. If the polynomial has 3 terms, if it's a trinomial, you do have perfect square trinomials, which are either in the form a squared plus 2ab plus b squared or a squared minus 2ab plus b squared. Remember, in both cases, the first term is something squared, the last term is something squared, and the middle term is twice a times b. So whatever this was squared and this was squared, that's your a and your b, multiply them together and double it. Okay, if it fits into that pattern or with the minus there, you're going to factor it into a plus b squared or a minus b squared. It factors into the same thing squared. Like the same thing times itself, or you can write it squared. That's the only special trinomial we have. Otherwise, we're just doing trial and error, which is you just trying to factor into 2 binomials. And the method that we're going to learn today deals with if you have 4 terms. The only way to factor 4 terms is by grouping. Okay, not all 4 terms can group, but if it can be factored, it can group. So grouping does involve pulling out a GCF 3 times, and I will show you what that looks like today. So looking at the extra practice, here we have things that are all 4 terms. And we're going to factor by grouping. You're going to make them into 2 groups of 2. Technically, it does not matter how you group, but most of the time you can group the first 2 together and the second 2 together. So looking at the first 2 here, do these 2 terms have some common factor? What goes into both of these terms? B squared does, because this has a b squared and there are 2 b's in here. So you're going to factor b squared out front, and then what do you have left? You're going to have a b minus 4. So that is the first GCF. Remember, we're going to do this 3 times. So then you're going to look at the second set, and is there a greatest common factor? And there's not in this case. This only has a b, this only has a 4. There is nothing that they have in common. But what we're going to do is we're going to say, let's imagine we pulled a 1 out, and you would be left with b minus 4. So the next thing you need to see is that this is a b minus 4 and this is a b minus 4. So now what you have is this is one term because it's being multiplied together, and this is one term because it's being multiplied together. And those 2 terms have a b minus 4 in common. So if we pull b minus 4 out front as the greatest common factor, so this is pulling it out front, what you have left is b squared plus 1, and that is your answer right there. If you FOILed it, you would get back up here where you started. Okay, let's look at number 7, and then I'm going to give you time to pause and see if you can do 2 and 8. Okay, so you're going to group. We have this first group and then the second group. Okay, does the first group have something in common? Is there something that goes into both these terms? Well, 4 goes into 4 and 12, and x squared goes into x squared and x cubed. So your greatest common factor is actually 4x squared. If you pull out 4x squared, you are left with x minus 3. Okay, you can check this by distributing. Okay, that gives you 4x cubed, and that gives you a minus 12x squared. You should be able to get back to where you came from. Looking at the other set, It looks like a 5 goes into both. Now, here's where we just need to be a little careful. We want to end up with this like same binomial thing. That's the only way this works if those binomials are the same. Well, this is a minus in the middle, and this currently is a plus in the middle. So what we actually want to do is we want to factor out a negative 5. So if you pull a negative 5 out of negative 5x, you're left with just the x. And then if you pull a negative 5 out of a positive 15, you're actually left with a negative 3. Because if you distributed negative 5 times negative 3 would give you that positive 15. So now if you'll notice, they both have this x minus 3. That's your third GCF that you're pulling it out front, and you're left with 4x squared minus 5, and that is your answer. So why don't you pause it and see if you can do the other two. All right, hopefully for 2 you got the quantity of c plus d times a plus b, and then for 8, 7h plus 6 times 3h squared minus 5. So let's go on and look at factoring completely. All right, so the very first thing from the flowchart is you're always going to look for a greatest common factor. So looking at number 9, is there anything that goes into 4c cubed and 4c? Well, hopefully you said they both have a 4 and a c. So if we pull out 4c, you are left with c squared minus 1. Okay, so anytime you pull out an entire term, you have to put a 1 in its place because you have to be able to distribute and get back to where you came from. If you can't get back to where you came from, you've done something wrong because you're not making these into new problems. You're just taking it and writing it in a new way. Okay, so you got your GCF out. Now if we look what's left is this c squared minus 1 based on our flow chart, and you might have written down that flow chart. You're looking at a binomial. Is this binomial, does it happen to be a difference of squares? Okay, so to kind of answer that, is this first term something squared? It is c that's being squared. And is the second term something squared? It's a 1 that's being squared, so it is a difference of squares. So your 4c is going to hang out front. Differences of squares factor into a plus b and a minus b, so you have c plus 1, and we have c minus 1. I'm sorry, my stylus doesn't work really well. C plus 1 and c minus 1. And that one is factored completely. What you have here cannot be factored anymore. Why don't you pause and see if you can do 10, because it's really like 9. All right, hopefully you pulled out the 25x squared as your greatest common factor. What you were left with was a difference of two things that are squared, so it factored into 2x plus 1 and 2x minus 1. Okay, and you need all three of those things in your final answer there. So let's look at 11. 11 is a trinomial. Okay, so the first thing that we're going to look for, GCF, is there something that goes into all three terms? Besides 1, there's not. Nothing goes into 2, 3, and 2, and then you have an a squared, an a, and a no a. So there is no GCF. It has 3 terms. We're going to check to see if it's a perfect square trinomial, of which it's not, because 2 is not a whole number squared. Neither is that 2. Okay, so it's not a perfect square trinomial. So you're just going to go into trial and error. I need to factor this into 2 binomials. Remember, the first are going to multiply to be the first. And how we make 2a squared is we need a 2a and an a. Then we're going to have last times last, and it's going to have to be a 2, which has to be a 1 and a 2. That's the only thing that multiplies to be 2. So the question just is, where do you put these? Okay, and so just by trial and error, and knowing kind of what your signs need to be. Remember, you need to look at that sign first, which is going to tell me they need to be opposite signs. I'm going to put the 2 over here, so that's going to make a 4a. And I'm going to put the 1 here to make a 1a, and I think I can make a 3a out of 4a and 1a. Okay, I'm going to put the plus sign over here, and I'm going to put the minus sign here. So if I have a positive 4a and a negative 1a, that's going to make a positive 3a. And then if I multiply negative 1 times positive 2, that will be a negative 2. Remember, you check these by foiling. So if you're curious about whether you've done that right, you just need a foil and see if you get back to where you started. All right, let's look at number 12. So we're going to check to see if there's a greatest common factor. And there's nothing that goes into 9, 3, and 14, and not everything has an x, so there's no greatest common factor. So we're going to go and we're going to draw our two binomials. Oh, I did check. It's not a perfect square trinomial because 14 is not some whole number squared. All right, so we have to figure out what we want to try for first and first. Okay, so this one has two options, and either 9x and 1x or 3x and 3x. So maybe we try 3x and 3x. And on the other side, for last and we're looking at 14. 14 is 1 and 14, or it is 2 and 7. And so the question then is, where do we put these numbers? So maybe we put, let's say 1 and 14. So with, was that a 42x and a 3x, can I make 3x? No. Okay, so if I switch 1 and 14, that's not going to do me any good. So maybe I use 2 and 7. So with a 21x and a 6x, can I make a 3x? No, and I can't switch. If I switch the 2 and the 7, it's the same thing because they're both 3 and 3. All right, so then maybe it's not 3 and 3. Maybe it is 9x and 1x. All right, so then if I use 1, let's do 14 and 1 with a 9x and a 14x, can I make 3? I don't think so. All right, well, if I switch them and I put the 14 over here, 9 times 14 is nowhere near 3, so I know that one's not going to work. So what about the 2 and the 7? Maybe it's 2 here and 7 here. Okay, with 18 and 7, can I make a 3? Nope. Okay, so there are occasionally times that things are not factorable, and you just have to try all your options before you can say that. Now, there is one other method of factoring I haven't gone over in the videos. If you'd like to attend a live session, I will go over that, especially now that you know grouping, which is what you need for that other method. All right, well, let's look at 13. And what should we always check for first? Greatest common factors. So notice that everything here has a 2 that goes into it. So we're going to factor out a 2, which is going to leave us with a 10p squared minus 11p minus 6. And sometimes they're done right then. Like there's not any more factoring you can do. But we are going to see if we can go further. So we're going to leave that 2 out front. We're going to do our two binomials. Remembering that first times first has to be 10p squared. You got two options, 1 and 10 or 2 and 5. Oh, let's try 2 and 5. So 2p and 5p. On the other end, remember those need to be 6. And again, you have two options. You have 2 and 3 or 1 and 6. So I'm going to do 3 here to make 15, 2 here to make 4, because I believe with 15 and 4, I should be able to make an 11. Remember, you look at this sign first that tells you they're going to be opposite signs, and I want to make a negative 11. So I'm going to do a negative 15 plus 4, okay? And I'm going to believe this is my answer, but if I want to check it, I could always FOIL it. So leaving the 2 out front, what do I get for first? 2p times 5p, that is 10p squared. And then outside is a positive 4p, inside's a negative 15p, last is a negative 6. If I combine like terms in the middle, that's a negative 11p. And then if I distribute my 2, 20p squared minus 22p minus 12. And that's how you make sure that you have it right, is if it foils out to be what it started. All right, why don't you try number 14 and we'll see how you do. All right, hopefully you pulled out the GCF of 4, and then your trinomial that was left did factor into 3x plus 4 and x minus 3. All right, looking at 15 and 16, recall that if it has 4 terms, 1, 2, 3, 4, the only way to factor these is by grouping. Now, they might have a GCF to begin with, so you can look for those. I don't believe either of these have a GCF. So to do your grouping, okay, we're going to group into 2's. So what do the first 2 have in common? They both have an s squared, which would leave a 3s plus 2. And then the second 2 have a negative 7. So we're going to pull out a negative 7, which leaves you with a 3s plus 2. And you can check that. There's negative 21s and there's negative 14. So they each have that 3s plus 2. We're going to factor that out to the front. You just pull it once out to the front. Don't pull it out twice. Like GCFs, you just pull out once. And then what's left is s squared minus 7. Okay, why don't you try number 16? All right, the first 2 had a t cubed in common. Remember when you pull out a whole term to put a 1 in its place. The second 2 had a negative 5 in common. By the way, you always need a sign right here in the middle. If you don't put a sign there, technically you're multiplying and that is not correct. They both ended up with a 2t plus 1. We pulled that out front, which left us with a t cubed minus 5. All right, one slide left and we're going to look at some solving. For solving, remember we use what is called the zero product property. It's the only thing we've used so far. We've used it most of the chapter. Zero product property does mean it needs to be equal to 0. It needs to be written as a product, which means actually to factor. And then, well, it's a property. All right, we are going to look at number 17. So is it equal to 0? Yes. All right, so we're going to factor it. Same rules on factoring. You're going to look for GCF first. Hey, 3 goes into all of these. So we're going to pull out 3. Okay, we're not done factoring yet. So this is the factor completely. So I'm going to leave that 3 out front. And then I'm going to try for 2 binomials here because that is not a perfect square trinomial. We're going to do x and x. To multiply to be 10, we have 1 and 10 or 2 and 5. Well, 2 and 5 would help me get to 7, so I'm going to do 2 and 5. It says my signs are the same. They're both negative. Okay, if I FOIL that out, a negative 5x and a negative 2x would make a negative 7x. And then remember the last part of the zero product property is you take every factor and you set them equal to 0. Now, so I'm going to set 3 equals to 0, and then x minus 2 equal to 0, and x minus 5 equal to 0. And you might go, hey, Mrs. Wag, 3 does not equal 0. Yes, you are correct. So that one we can just cross out. Now, I wanted to write that though because occasionally you pull out an x, and then you do need x equal to 0. That is one of your answers. Okay, as a little heads up, you will have as many answers as your highest degree. In this case, my degree was 2, and hence I had 2 answers. Why don't you pause and see if you can do 18, and then we'll resume and do 19 together. All right, hopefully you pulled out the 5 as the GCF. Then you factored your trinomial into 2 binomials. They were y minus 3 and y plus 2. You're then going to set all 3 factors equal to 0. Remember, we do that because sometimes this is an answer. If it is a false statement, though, it's been a while since we said that. If it's a false statement, you're just going to cross it out. 5 does not equal 0. add the 3 over, you get y equals 3, and subtract the 2 over, you get y equals negative 2. So on the last one, we're going to do it the same way. You're going to look for GCF, and our GCF on the last one happens to be c squared. So you're going to pull out your c squared. That leaves you with c squared minus 81. What you have left, this binomial is a difference of squares. This is c that's being squared and 9 that's being squared. So it can factor into c plus 9 and c minus 9. You are then going to set all 3 factors equal to 0. And I think I forgot my c up there. It got in my parenthesis. All right. Here's a skill we haven't really talked about yet. We're going to square root both sides, and you get c equals 0. Okay. That one is an answer, and actually because there's a squared, it's a double root. We briefly mentioned that earlier in the chapter. The second one is c equals a negative 9. And the third one is c equals a positive 9. Okay, so you have 3 answers, and you hopefully heard me say earlier that you're going to have as many answers as your highest degree, which is 4. But this one here was a double root. C actually equals 0 twice. Another way I could write that here real quick is this is c times c equals 0. So I can actually set both those c's equal to 0, so you can see that it's a double root. All right, let me know if you have questions. I know there's a lot happening here, but factoring is oh so important as you continue on your math career, so we want to make sure that you get plenty of practice. Let me know if I can help you, and have a good day.